Hello, my name is Shivani. I am one of the new Wyzant tutors here, and I am here to help you with your physics problem. And it looks like it involves related rates. So let's start by taking a look at the question. So a plane is flying parallel to the ground at an altitude of 1 mile. The plane is traveling at a constant speed of 500 miles per hour, and at 1 o'clock p.m., the plane passes over a radar station on the ground. Find the rate at which the distance from the plane to the radar station is changing exactly 6 minutes later, which is at exactly 1:06 p.m. So I have drawn out the scenario here. So this right here is the horizontal distance between the radar station down here and the plane, and I called it X. Y is going to be the vertical distance, which is constant at 1 mile, since according to the question, that's the altitude of the plane. And then H is going to be the total distance from this radar station right here to the airplane right here. I know that's not the best drawing of an airplane, but I tried. So let's get started. So the question is basically asking for the rate of change of this distance right here, h, at 1:06 p.m. So at 1 o'clock p.m., the plane is exactly on top of the radar station down here. And at 1:06 p.m., the plane is some horizontal distance x. So given the fact that it's traveling at 500 miles per hour, let's calculate the distance x, the horizontal distance x, at 1:06 p.m. So 6 minutes is 0.1 hours, or 1/10 of an hour. So at 1:06 p.m., the plane has traveled for 0.1 hours, or 6 minutes. And the distance that it's traveled can be calculated by using the speed times the time. So it'll be 500 miles per hour times 0.1 hour, which would be 50 miles. So this x right here is 50 miles. So at 1:06 p.m., the horizontal distance is 50 miles. Now, this problem involves related rates. So we know that dx over dt, the rate of change of the horizontal distance over time, is the speed of the plane, which is 500 miles per hour. And then the rate of change of this distance right here, dh over dt. So that's the rate of change of the distance between the radar station and the plane, this hypotenuse here, over time. And that's what the question is asking us to find. And then another derivative we have going on is going to be dh over dx. Now let me first write an expression for h in terms of x. So based on the Pythagorean theorem, we can look at this as a right triangle. We have x squared plus y squared is equal to h squared. Now, y is constant at 1. because the plane is traveling at a constant altitude of 1 mile. So we can say x squared plus 1 squared is equal to h squared, or x squared plus 1 is equal to h squared. So then h would be equal to the square root of x squared plus 1. So now that we've expressed h as a function of x, we can go ahead and determine dh over dx. That's the rate of change of h with respect to the horizontal distance x. So for this right here, we need to use the chain rule. But before we do that, let's first express this square root as a fractional exponent. So h would be x squared plus 1 raised to the 1/2 power. So now we can use the chain rule to determine dh over dx. So u is going to be our inner function. So we can rewrite this function as h equals u raised to the 1/2 power, where u is going to be the inner function, x squared plus 1. And du over dx is equal to 2x. That's based on using the power rule for x squared. So now we can write dh over dx in terms of u. So dh over dx is equal to d over dx, x squared plus 1 raised to the 1/2 power, which is d over dx, u raised to the 1/2 power, and that would be equal to d over du of u raised to the 1/2 power times du over dx. So dh over dx would be equal to the derivative of u 1/2. So using the power rule, it would be 1/2 u raised to the negative 1/2 power times du over dx. So that would be equal to 1 over 2 u raised to the 1/2 power. So remember, if it's a negative exponent, it goes in the denominator. You would do that times du over dx. And that would be equal to 1 over 2 x squared plus 1 raised to the 1/2 power times du over dx, which is 2x. So then dh over dx would be equal to 1/2 of the square root of x squared plus 1 in the denominator times 2x. So then dh over dx, I'm actually going to use a different color here. So we could cancel out 2 and 2. So the final answer for dh over dx would be x divided by the square root of x squared plus 1. All right, so now that we have dh over dx and we have dx over dt, we can write an expression for dh over dt using dh over dx and dx over dt. So dh over dt, again, that's the rate of change of that hypotenuse distance between the radar station and the plane. That would be equal to dh over dx times dx over dt. And then notice how the dx and dx cancel out in this calculation. You're left with dh on the numerator and then dt on the denominator. So now that we've derived an expression for dh over dt in terms of dh over dx and dx over dt, we can compute the value of dh over dt when x is equal to 50 miles. Because if you recall, we found that x was 50 miles at 1:06 p.m. And the question is asking us to find the instantaneous rate of change of this distance x at 1:06 p.m. So we can go ahead and substitute x equals 50 miles. So let's first write this expression. So dh over dt, dh over dx is the expression that we computed in the last page. And that would be x over square root of x squared plus 1 times dx over dt, which is 500. And that's the 500 miles per hour that the plane is traveling at. So x equals 50. So let's go ahead and plug and chug. So dh over dt when x equals 50 is equal to 50 over square root of 50 squared plus 1 times 500. And when I plug that into the calculator, I get exactly 499.9. And that would be in miles per hour. Now, notice that this is so close to the speed that the plane is traveling at. So we can go ahead and check whether our answer makes sense. Now, if you think of this scenario here, note that this drawing is not to scale. So the vertical distance is only 1 mile, but the plane is traveling very fast. It's going at 500 miles an hour, and it covers 50 miles in just 6 minutes. So if you think of it, this hypotenuse distance right here should be pretty close to the speed that the plane is traveling at. And that makes sense with our answer being so close to the actual speed of the plane. Since this distance is so small compared to the speed of the plane. So, yeah, our final answer for this question would be 499.9. And I don't know whether they want you to round or not, but if they want you to round, it would be 500. But yeah, that pretty much sums up the answer to this question and the explanations. If you have any questions, feel free to leave it in the comments section. And I hope this helps. Thank you and have a wonderful day.